I'm going to ask you what should be a simple question. Are you moving right now? If you're sitting at a desk in front of a computer, you probably answered no. But in fact, you're moving at an insane speed. Right now, you are rotating around the Earth at a velocity of 770 miles per hour east. The Earth is also orbiting the Sun at 66,000 miles per hour. And then the solar system is moving towards other solar systems at 43,000 miles an hour, approximately in the direction of Hercules, while also orbiting around the center of the galaxy at 483,000 miles per hour in the direction of Cygnus. And then the whole galaxy is moving towards other galaxies at 1.3 million miles per hour, causing us to move in a direction between Leo and Virgo. So yes, you are moving. To figure out your total velocity, you would have to add up all of these velocities as vectors and find the total. You can't tell you're moving because your body can only feel acceleration. When you move at a constant speed, you can't feel much of anything. Just like how it doesn't feel like you're moving when you're on a really smooth plane ride. But technically, when you answer, no, I'm not moving, you're also not really wrong. That's because it depends what we're measuring motion against. Relativity tells us that no motion is absolute. Relative to the Sun, you're moving at 66,000 miles per hour, but relative to your desk, you're probably not moving at all. Both are just as true. Motion is relative. It depends on your point of view, on where you're viewing that motion from. So really, motion is just movement relative to some other object or frame of reference. There is one basic equation of motion that everyone should know. It says that speed s, measured in meters per second, is equal to distance d, measured in meters, divided by time t, measured in seconds. If you travel 10 meters in 2 seconds, then you've traveled 10 divided by 2, or 5 meters per second, which is to say 5 meters in each second. If your speed isn't changing, then that's all there is. But if your speed is changing, then the equation changes to say that your average speed equals your total distance divided by your total time. And if your speed is changing, that means you're accelerating. And acceleration is just a change in velocity over a period of time. The equation for acceleration, a, measured in meters per second squared, is final velocity, vf, measured in meters per second, minus initial velocity, vi, also measured in meters per second, divided by the time it took for that velocity to change, t, measured in seconds. Maybe this will be clearer if we enter an example. Let's say that you're riding a bike, and you ride for 5 seconds traveling 6 meters. Then you instantly speed up and travel 10 meters in 4 seconds. And the question asks you to calculate your speed during the last 4 seconds, and your average speed during the whole motion. To figure out your speed in the last 4 seconds, you just do speed equals distance divided by time, which is 10 divided by 4, which works out at 2.5 meters per second. But then to get your average speed during the whole motion, you take your total distance and divide it by your total time. Your total distance is 6 plus 10, which equals 16 meters, and your total time is 5 plus 4, which equals 9 seconds. Divide 16 by 9 and you get 1.78 meters per second. So your speed in the last 4 seconds was 2.5 meters per second, and your average speed over the whole motion was 1.78 meters per second. And then let's say you're given a bit more information. Let's say that the speeding up period between the two speeds wasn't really instant. After all, who can instantly speed up on a bicycle? That's impossible. It always takes some time. And let's say it took 2 seconds to increase the speed of the bicycle from 1.2 meters per second to 2.5 meters per second. What was your acceleration during those 2 seconds? Well, acceleration is final velocity minus initial velocity divided by the time it took for your velocity to change. So that's 2.5 minus 1.2 divided by 2, which equals 0.65 meters per second squared. So that's your acceleration. And that's it, we're done. You might not think you're moving, but you're actually rotating on the Earth, orbiting around the Sun, orbiting around the center of the galaxy, and zooming to collide with Andromeda. You're moving a lot. The saying that you're not moving isn't really wrong either. Motion is relative. It depends on your point of view, or where you're viewing that motion from. Motion is just movement relative to some other object or frame of reference. The basic equation for motion says that speed s measured in meters per second is equal to distance d measured in meters divided by time t measured in seconds. If your speed is changing, then the equation changes to say that your average speed equals your total distance divided by your total time. And if your speed is changing, that means you're accelerating. And acceleration is just a change in velocity over a period of time. The equation for acceleration says that the acceleration a, measured in meters per second squared, is equal to the final velocity vf measured in meters per second, minus the initial velocity vi, also measured in meters per second, divided by the time it took for that velocity to change, measured in seconds. As long as you understand the information you're given, you can just plug numbers into these equations and solve for the missing variable. It's really that simple.